feature of the calculus to do the integral, you can get the from the position, the acceleration function. Okay, so if you know the acceleration function, AP, you can get velocity function by integral. Okay, and then you can get the position function. So what we get is if AT equals to a constant A. If you have a constant acceleration motion, then if you integrate it, you can get some equation like this. First, you are going to get V equals to V naught plus AT. And integrate this, you get delta x, or x equals to x naught plus v naught t plus 1/2 a t squared. Okay. So these two are the two fundamental equations for our kinematic equations. Okay, so here. And we have these two equations. Okay. In principle, you can combine the two equations to solve all the problem. And to simplify some of our problems, we introduce two auxiliary kinematic equations. This one and this one. And these two can be derived from these two fundamental equations by some algebraic manipulation. Okay. I will leave this process for you to do it by yourself. You don't have to use the integral for these two. You can just combine these two to get this and this. Okay. In fact, it's very straightforward. For example, if you combine these two, you have two equations. If you combine them and get rid of t, you are going to get this equation. Okay. If you combine these two and get rid of a, you get this equation. Okay. Now, one comment I would like to add is that, in fact, from this equation, you can also show this. The average velocity equals to 1/2 v naught plus v. Okay. You can show it from here because delta x equals to 1/2 v naught plus v multiplied by t. But if you divide it by both sides by time t, you get delta x divided by t equals to 1/2 v naught plus v. But on the other hand, this is the definition of the average velocity. Okay, the distance divided by time interval. So that means this one has to be average velocity. Okay, and you can see here, of course, this is very understandable. This is the initial velocity, this is final velocity, add them, divided by 2. This gives you the average velocity. But again, what I would like to emphasize that this kind of calculation is only correct for constant acceleration motion. Okay. So if the velocity increases with a constant rate, to find the average velocity, you can simply add the initial velocity, final velocity divided by 2. But if the velocity increases with a non-constant rate, you cannot simply add the initial velocity and final velocity divided by 2 to get the average velocity. Okay. So all these equations are only true for the motion with constant acceleration. So that's something you have to pay attention to. Here, we use the calculus to show the two fundamental equations for this kind of simple motion, constant acceleration motion. In fact, the calculus is a very powerful tool. It can be used to calculate very complicated motion. Even the acceleration, the force, is not constant. You can still do the integral, okay, to get the velocity function and the position function. So this work was has been done by the Sir Isaac Newton.